So, dear participant, good evening. So, good evening, madam, Anita, madam.
Yeah, so good evening, sir.
So, Rasagna, so please introduce about the speaker.
Okay, sir. Good evening, everyone. Myself, Rasagna. And I would like to call upon Dr. Anita Raghavendra, ma'am, a specialist learning in artificial intelligence and machine learning, track Infosys, having 13 years of teaching experience in various engineering colleges. She has done BE in electronics and communication and MTech in digital communication and networking. She obtained PhD from Mysore University, and also she published more than 10 papers in reputed journals and conferences. Anta, ma'am, I would like to hand over the session to you, ma'am.
Yeah, so thank you, madam.
Thank you, ma'am.
Thank you for introducing me to the audience participants.
Yeah, it's my pleasure, ma'am. So, thank you.
Yeah, so thanks for giving me an opportunity to share. Okay, let me on video just confirm, is this visible?
Yes, madam, visible. So, I have given co-host, madam. Please share the PPT, madam.
Yeah, sure. Yeah, I would like to thank you people for giving me an opportunity to share my, ideas, research ideas. Okay, and share my knowledge. Thank you. Give me a moment. Let me share my screen. Okay, can you just let me know, is my screen visible?
Yes, madam, it is visible. Madam.
Thank you so much for the conversation. Yeah, so good evening, everyone.
Ma'am, you have to give break at 7:50 to 8 o'clock, madam.
7:50 to 8, right?
8 minutes, 10 minutes.
Okay.
And you close the session 9 o'clock, madam. 9 o'clock.
Okay, sure. Okay, sir. Thank you.
Thank you, madam. Thank
you. So let me put it in the slide mode. Okay, I hope my voice is clear as well as my screen is visible, right?
Yes, madam.
Yeah, thank you. Okay, once again, good evening, everyone. Today's presentation topic is on AI, it is artificial intelligence and machine learning approaches for quality evaluation of mangoes. So I did my research in the same area. Okay, so mangoes anyway. So I'll in between, so I would like to convey why I have opted this area, especially on mangoes. Okay. Anyway, so before we get into that, or before we dive in, I want to give you some introduction on this, like agriculture. So as you all know that in Indian agriculture, horticulture plays a very important role. Okay, and the reason is because fruit industries contribute a major part in their economic growth. Okay, and if you ask me how, in what sense, that is, so due to export of superior quality fruit and customer, demand satisfaction. Okay, and and you know that there is a many challenges and competition in exporting many products to different countries. Okay, so to strengthen the export, to strengthen this export competitiveness, a post-harvesting technology is required. I hope you are aware of this post-harvesting technology. So there are different, steps in post-harvesting. So post-harvesting technology is required. And to have, so efficient post-harvesting technology, precision agriculture is being used for the last 2 decades. I hope you're aware of precision agriculture. It's like, so optimal way of adopting many techniques in the field of agriculture. Okay. And there are many applications of precision agriculture. It's like applications of precision agriculture in post-harvest management, post-harvesting process management system, or is to have sensors to monitor the conditions. And sometimes it can even monitor, like we can have different sensors to monitor the condition, and we can use sensors to monitor like a storage level, okay? So like food storage or fruit storage level. And we can also have sensors for the purpose of grading and sorting of fruits. Okay, with this brief introduction, I would like to walk you through our next part, that is how this AI and ML could be used to evaluate, or the quality evaluation of mangoes. Okay. Just a second. Okay, so, and of course, we all know that mango is our national fruit, right? And the mango is the most delicious, is one of the most delicious fruit, so produced and consumed throughout the world. Okay, I hope you know this, isn't it? Okay, so like here, India is one of the most prolific mango growers. So you know this, here, India constitutes about 57% of the worldwide production. Okay, so worldwide production. And so there is a huge demand for mango, both in local markets as well as in international markets. Okay, so look at the number. It is 57% of the production happens from India. Okay. And these are, and unfortunately, I think, yeah. So unfortunately, recent days, European countries have Indian mangoes. Okay. Anyway, so I want to highlight what could be the reason. But many countries, European countries, and many more countries have banned Indian mangoes. Okay, so they assume that Indian mangoes are not good. Okay, that is affecting to again Indian economy. And yeah, so this is how mangoes are being graded and sorted while exporting. Okay, so to different countries, and based on many criteria, so this mangoes are being graded and sorted. So let's. Okay, so try to understand what are, sorry, yeah. So what are the issues? So if you ask me, so what could be the, so different issues where still some like major research is happening in the field of agriculture, and of course in mango fruit. Okay, the issues are like ripeness of mango, because like here, you know that different stages of mango, like ripened mangoes, okay, so can be used to produce or produce different food products, isn't it? Because raw mango can be used to manufacture pickles and some stages of mango. I mean, no, so mangoes which are under ripen, which is in the mid stage, okay, middle stage, like it is not unripen and over ripen, okay, and those kind of mangoes can be used to like manufacture different products. Like, okay, so it could be a jam, it could be jam or something, and sometimes so over-ripened mangoes can also be used for ice cream. So different food products can be made with different stages of different ripening stages of mango. So this is very important, like identifying or categorizing the mango. So based on their ripeness level is one of the major issue. And so of course, coming to the grading part, like grading of mangoes, right. So here, which can be easily understandable by the consumer. Like if you go to the market and if you would like to so buy some mango, so how do you pick it up? So based on it could be based on the color, or it could be based on like the texture of the mango, and sometimes even the defects like black spots on the mango, because you don't buy such kind of mangoes when it has any defect, especially appearance wise, isn't it? So grading of mangoes is also very important. And so recognizing artificial ripened mangoes. So this is, so this leads to a major issue. So you all know that nowadays mangoes are being so ripened with the different types of chemicals, okay, recognizing artificial ripened mangoes and detection of internal defects in mango. So because of, so these many reasons, most of the countries have banned Indian mangoes, okay, especially the last one is very, very crucial. So detection of internal defects in mango. See what they do, like, anyway, I'll come to this in the later part, like why it is playing a major, so issue. I mean, what could be the major drawback or the reason why many countries have banned Indian mangoes. Okay. And keeping all these issues in mind, so in future, like we can propose this kind of a post-harvest management system that is for mango grading. Okay. As you can see, like we have different sensors in the different stages. Okay, at one time, that is at one system. So we can have different steps or different, so solution for different problems, like issues what we have discussed in the previous slide. So initially you can allow mangoes, so to pass on the conveyor belt, as you can see here. I hope you can see my cursor. Is this so? Can you see the cursor? Can you please confirm?
Yes, madam. Yes, madam. Yes.
Okay, yeah, thank you. So we can allow mangoes, so pass on the conveyor belt, right? And we can keep the camera here. Okay, we can fix up the camera. So where camera captures the image, captures the mango images, and in the first stage of sorting or so classifying the mango, we can adopt a system, like we can build a machine learning or artificial intelligence model to separate the mango or to categorize the mango based on the ripeness level. Okay, so like as I mentioned, we can have so AI model here. Okay, and at the initial stage, you can see it is getting classified in two stages, like underripe and ripened one. Okay, because the issues what we have discussed here, it is all about like the last 2, 3, 4. So these issues we can work on, or we can so take these issues into consideration for ripened mangoes. Okay, it's not we cannot so build a model for unripened mangoes. So that can be done at the first level. So that is what you can see here. Okay, initially we can allow our ML model. We can build a ML model to segregate mangoes as underripe and then ripened one. And once it is being ripened, okay, once we identify the mango is ripened, then we can have another sensor. Okay, you can see a camera here. We can have another sensor to categorize whether it is naturally ripened or chemically ripened. Okay, so naturally ripened or chemically ripened. And in the later stage, because see all these, like the first two issues can be solved with a simple, using a simple camera. Okay, so images are enough to find or to categorize underripe, ripe, and then naturally ripened and chemically ripened. I don't know. So how many of you are aware of or recognizing, of naturally ripened and chemically ripened? Okay, like what knowledge you have got, I don't know. So anyway, so I'll just give you some idea that how you can recognize it, because consuming chemically ripened mango leads to many health issues, as we all know that, isn't it? Okay, and in the later stage, we can introduce another sensor called NIR spectroscopy. Okay, so NIR stands for near infrared spectroscopy, where this spectroscopy can be used to detect the internal defects in mango. Okay, because using normal camera, it is not possible, isn't it? So using normal camera, it is not possible to detect the internal defects. I don't know whether you have observed this issue, like white patches or spongy tissue which occurs internally. Okay, that can be identified or detected only with the help of spectroscopy called, it is NIR, near infrared spectroscopy. Right, in the later stage, we can have this spectroscopy to detect whether it is a healthy mango or internally defective mango. Okay, and if you ask me why this kind of mango, I mean chemically treated mangoes needs to be segregated as healthy mango and internally defective mango, because anyway it is not going to be, we are not going to consume, isn't it? once it is detected as chemically ripened, then we are not going to consume as well. Yes, but still, so we can have NIR spectroscopy to identify or to categorize healthy one, and because sometimes even these kind of mangoes can be used to manufacture, any medicines kind or anything. Okay, so these kind of applications we can do with the chemically ripened mango. Okay, so this kind of system, post-harvesting management system, can be proposed to our, that is especially while exporting mangoes to different countries. And as I mentioned, many countries have banned Indian mangoes. So in future, we can propose this system. Okay. Yeah, so I think you are aware of the ML process, like different stage which comes in ML, machine learning. So we can have the samples. It could be in the form of images, or it could be in the form of NIR spectroscopy data. So you can see both the data here. Okay, because in the first two cases, we have used cameras, right, to get the images. And in the next case, we have, I mean, in the last stage, we have used NIR spectroscopy. Okay, where we can have a plot reflectance versus wavelength. Okay, you do not get in terms of images, right? And so these inputs can be given to the pre-processing or the segmentation technique, right? Image processing needs to be done sometimes, some segmentation like capturing or extracting only the foreground, okay, removing the background. We can, so proceed, and further we can extract the relevant features. So depending upon the issues or depending upon the application. See, in the same area, we have identified so many issues, isn't it? Like how we can segregate the mangoes based on their ripeness. In that case, the feature could be different, right? And in some cases, like chemically ripened or naturally ripened, like features could be different. So feature selection or extraction needs to be done in the next level. And once it is done, so we go with the classification. And before that, I think you are aware of splitting the data set. That is for the purpose of learning. Okay, so we allow our machine to learn. That is called machine learning. So for that purpose, that is for the purpose of learning. So we need to divide the entire data set into training and testing, right? In the training part, you will have some data. So you can build a ML model further. So we need to evaluate the model. Okay, so further classification will be done, right? And ultimately, it can recognize the class sample. So this is the basic architecture of ML process of machine learning model. So at any point of time, you can stop me and ask questions if you have. Okay, you need not to wait till end. This is fine. Okay, feel free to ask. So I would like to take it up even in between. Okay. So here I want to highlight what were the challenges we faced during the collection of data set, because in my research, I have collected my own data set. I worked on my own data set. Okay. It's like, so I would like to give you some idea of my, so research journey. It's like, so starting from a collection of data set until, till I got the output, right? The first and foremost challenge was when I decided to collect some samples of the mango, because I had to capture many like images of the mango. Okay, so so I bought nearly 230 mangoes, and 230 mangoes I had kept it for ripening. Okay, and after 1 or 2 days, and of course at the initial stage, so I was not knowing whether I need to check every day and like alternative days, right? So I just did experimentations, and after 2 days, I mean, I assume that so it gets ripened after 2 days or 3 days, because that it takes some minimum 4 days to get ripened. And if it is getting naturally ripened, then so it takes 10 to 12 days. But when you keep it for ripening with some chemicals, so it gets ripened very quickly. So within 3 to 4 days. So some mangoes I had kept it for ripening. I mean, naturally, okay. So natural process, with the natural process, I just followed natural process of ripening, and the other one, so chemically, I've just, I had just put chemicals. And after 2 days, when I checked, when I just opened the box, it was, so completely 230 mangoes were, so turned out to be black. So I could see all the black spots on the mango just in 2 days, because when I bought these mangoes, it was healthy. Okay, so it looks healthy. But after 2-3 days, when I just checked, it was completely dark. I mean, I could see some black spots on it. Then, so I had to cut each and every mango and check. It was, so worms were coming out of the mangoes. I could see many worms inside the mango. So how it happens, because even at that point of time, I did not have any knowledge that like how to choose the mango. And then later I got to know, so due to this hailstorm rain, I think you might have heard about this hailstorm rain. Okay, so because later I got to know, so most of these mangoes were affected by this hailstorm rain. Okay, so because of this, even when you keep these mangoes for ripening process, or so get ripened, it does not. Okay, so after 2 to 3 days, you can see a lot of changes on especially in appearance wise. Okay, that was the challenge, because see, again, most of like 230 mangoes, most of the mangoes were completely decayed. That was the first so difficulty I faced. So this was the challenge that I wanted to highlight. And sometimes even so due to over-ripened mangoes, like it is very so difficult to you can just create the data set. I mean, you can just create the ground truth, but at the same time, you need to cut each and every mango and check whether it is over-ripened or not. Okay, so these things need to be done, especially when you are collecting the data set. Okay, and I had to monitor so every ripening stage of mango. So I had to check alternative days, whether, because you need to check what could be the changes. Okay, what kind of changes it happens every day, isn't it? Sometimes even when you open and check every day, so due to some because it has to create some moisture, right? Okay, due to the moisture content and I mean some humidity, so it gets ripened quickly. So I had to check, or I had to monitor every ripening, different ripening stages of mango. So these were some of the challenges I faced. And even in case of like, because I had to travel from one place to, I had to carry mangoes from one place to another place, like to Bangalore, to get the kind of like NIR spectroscopy data. Okay, in that, I mean, during that time, like when I was just carrying the mangoes from here, from Mysore to Bangalore, so in bus, like worms were coming out of the mangoes, because I had to carry only ripened mangoes, like over-ripened mangoes. Okay, so I faced a lot of challenges during the collection of data set. And later, so once I mentioned that 230 mangoes were completely decayed, so I had to purchase few more mangoes. And then I collected the data set in 2015, and later I got to know, so I mean, this shouldn't have been done. So these things you understand, okay, stage by stage. And then in 2018, so so I collected few more images. And somewhere I understood that these images data set was not enough. Okay, so coming to the first part of the issue, like ripeness evaluation, like when we just referred the survey, I mean literature, so we understood that mangoes have been sorted, so based on their ripeness level, considering only two categories, like one is unripened and another one is so ripened one. And in some literature we found it is unripened, ripened and over-ripened. Okay, so because anyone can identify which is unripened, which is completely, I mean, which are completely green, isn't it? And some mangoes ripen. It is perfectly ripened, so easily we can identify with or recognize with the over-ripened, because you see some wrinkles on it, isn't it? Like wrinkles on over-ripened mango. Okay, so these three categories were there in the literature. Then we have understood nobody has done on the underripen. They categorizing the mango with underripen. Underripen means which are kept underripe. Okay, it's like, so middle stage. It's not completely unripened, so that can be easily recognizable because you see complete, green in color. Okay, mangoes in green in color, completely green in color, and ripen means anyway, so which looks completely yellow or orange kind of. So then we took the data set like underripe. So can we build a model so that it can separate underripe and then ripe? And even in the literature, we found that we found that they like built a model with a direct classification. Direct classification means like you have some samples, like let us assume like 100 samples. Out of 100 samples, like it needs to be, the model needs to be categorized as which is unripened one, which is ripened one, and which is underripened one. So easily you can have some features like common features like green and yellow color. Along with that, you can have texture because you see wrinkles on overripened. Okay, with some more than 80% accuracy we found. And then we decided, so why don't we approach, or why don't we propose hierarchical model? So this is what this is what happens in the industries, like fruit industries. So at the initial level, it gets sorted like underripened one and then ripened one, and then after it gets segregated as underripe and ripe, then probably we can work on the ripened one. Okay, so whether then we just had a thought whether we can separate it as a perfectly ripened, which is ready to eat. Okay, which is ready to eat, and overripened with black spots. See, look at the class samples we have taken here. Overripened with black spots. Why we have concentrated more on overripe with black spots is because so in many fruit industries, while so getting the mangoes from the farmers, so they assume that whichever the mangoes have black spots, okay, they assume it is not going to help. They just discard it. Okay, we understood that. So most of the mangoes are getting discarded in fruit industries, assuming that, especially when they have black spots on it, okay, in the skin area. Then we thought, because I don't know whether you have observed, though you have black spots on the skin area, but still the pulp area will be good to eat. Okay, did you ever notice that? Let us have an interactive session. I would like to have always, so interactive session. Did you ever observe that though you have a black spots on mango, but still, the pulp area will be good? I hope you're there.
Yes, ma'am.
Okay. Did you notice that anytime you find black spots on the mango, but still the pulp area will be good? But
yes,
in fruit industries, they just discard these kind of mangoes. Then we thought, why can't be, why the model can be, so model can be built so that it is able to separate black spots without internal defect, so that these kind of mangoes can be used further to manufacture some fruit products. Like it could be jam, or it could be ice cream, or something else. Okay, and black spots with internal defects. Okay, so here in the last stage, we have identified or segregated black spots without internal defects and with internal defects. So keeping all these constraints, we have developed or proposed a hierarchical model. And to do that, like we have extracted the color space features, like because we just tried out with different, like all the color spaces, like LAB, RGB, okay, so CMY and YCBCR, HSV. So we have, considered like extracted these individual features as well as the fusion. So fusion means like considering all the three features like LAB. Okay, instead of taking only this individual one, we have also tried with the like fusion or combining these three. Okay, because we wanted to know for which particular color feature we get a better result. Okay, to improve the accuracy of the model. So we tried out with the different features, individual features, as well as their fusion. And we also tried with the texture feature, because we at the last stage, like when you come to the last stage of hierarchical model, so the texture would be the prominent feature where it can recognize or categorize these two, because you would find the wrinkles on it, as I mentioned, in overripened mangoes. Okay, so we also tried with the texture feature like LBP, GLCM, and Gaber. Yeah, so in today's presentation, I'm not going to highlight the technical part of it. I just want to give you how we have built a model. Okay, how the different ML approaches have been used. That is for the quality evaluation of mango. And in the later stage, like after we extracted the features, we have used different classifiers. Like we just tried out with the combination of classifiers, like all the classifiers and combination of classifiers. So LDA, SVM, Naibi's classifier, KNN, and neural network. Okay, and like we have also proposed new classifier that is called threshold based classifier. So based on the threshold value between two classes. Okay, it's like, so, and if you ask me how do you keep the threshold, so on what basis you keep the threshold, it's like a minimum, and it is based on median, so minimum plus maximum divided by 2. So we have proposed this classifier. Okay, and these were the samples we have taken it for experimentation. Okay, and sometimes it is very difficult to classify the first level. I mean, see this, look at this one, the first one, it so this one and I think this one seems to be same, not exactly, but it is same. Okay, so then we thought this is quite challenging, like identifying or categorizing mango as underripe and then perfectly ripe. Okay, and these are some of the images where it has black spots. Yeah, so I was able to collect some like 979 images, approximately 1,000 images. Okay, and I had to check each and every day. It's like alternative days, whether it is ripened or not. It is in which stage it is. Okay, I had to create some ground truth on these data sets. So you can see the variation, like day 5, you can find only few, and day 7. And sometimes, so if you take the pictures on day 11, okay, so some of the mangoes would have, so been completely decayed. So that is why we were able to get only 50 images for the last part, that is overripe with black spots. Okay, so we could get only less number of images in the last stage. Okay, so this is the result I've got. I don't want to highlight much in this result part, but here, this is the first stage of classification. First stage means classifying underripe and then ripen one. So here SVM is working better, that is with LAB, fusion of LAB classifier. Anyway, so this is not properly visible. All the lines look same, seems to be same. Okay, for me, I have got a good result using SVM classifier and with the fusion of LAB. Similarly, I have also tried out with the same method, that is at the second stage, that is perfectly ripened and over-ripened with black spots. Okay, so this is for the last stage. I think here I'm getting good result for threshold-based classifier. That is with B. So this is the one. Need to use this highlighter. Okay. Yeah, so this is the one, this line. Okay. And later we have understood LAB color, because in all the stages, LAB works better. So here it is fusion of LAB, again in the second stage, fusion of LAB. And in the last stage, only the B, okay, B feature is working better. Then we have understood compared to other color spaces, so LAB gives a better result. Then we have, so taken only LAB result and compared this with the texture feature. Sorry, yeah. So you're getting maximum, you can see maximum result using LAB. Then we have tried out with a different texture feature like LBP, GLCM, and Gaber. Okay, so blue one is for the first stage, red one is for the second stage, and green one for the third stage. but you can see, so better result using texture also, but as there is no consistent result with the texture, so finally we have proposed LAB. Okay, and we have tried to plot this LAB 3-dimensional for these data sets. You can see red one and green one can be easily separated, and this is the result I have got. In the first level, we have got some 99.09, and in the second stage, 85.94. Okay, but here it is less, quite less compared to first level, because the last level is to segregate the samples as over-ripened, black spots with internal defects and without internal defects. Okay, and that too with the normal camera, getting this much accuracy is appreciated, right? And finally, yeah, so we have calculated the mean accuracy, and is the so equation to find the accuracy when we have hierarchical approach. And later, when we referred the direct classification, it's like multi-classification, and when we compared hierarchical approach with the direct classification, so this was giving the better result. Okay, like in terms of accuracy, precision, sensitivity, and specificity. Okay, so coming to our next, just a second. Yeah. Next issue, that is the classification of artificial and natural ripened mango. So this is a very crucial stage and crucial way of ripening the mangoes, because you might have noticed or heard about. Okay, you might have seen this kind of article, especially that gets published during mango season. Have you ever noticed these kind of articles during mango season? Yeah. So if you're interactive, then this would be more, so interesting, I guess. Session is going to be interesting. Have you seen these kind of different kind of article, which is purely on identifying artificial and natural ripened mango? Because so consuming such kind of mangoes, like chemically or like artificially, so ripened mangoes, leads to many health issues. Okay, majorly that leads to cancer, right? It may cause cancer, so blindness and stomach upset. So there are many health issues. Okay, so over the period of time, if you consume so mango, these kind of mangoes, that leads to cancer. Okay, so I think just 5-6 years back, the Indian government had banned calcium carbide. So CaC2 is the calcium carbide. So where they were used to, they used to have this calcium carbide, that is for the ripening process. It's a way of ripening the mango. Okay, and then we took this issue, and then we thought how this could be possible, like how we can build a simple machine learning model where it is able to separate or classify artificial one and natural one. And when I had inquired people who are in market, who sell mangoes, okay, I just asked them, like, how do you, of course, they do not reveal, isn't it? So they never reveal their secret. Okay, so because people might think that, they, of course, they say that it is naturally ripened. Okay, then I asked one of my so close friend to get the idea, like how this can be identified. And when I because I just inquired some senior people, like, can you identify which is natural ripened mango and artificial ripened mango? Okay, even today when you go to any website, okay, to check how it can be classified or how it can be recognized, so it says that so when you see so complete, uniform, when you see mango in uniform color, okay, uniform color, so they say that it is and it is more when the mangoes are more attractive. So that is why so we prefer you that not to buy attractive mangoes. Okay, any fruit which is more attractive, right? So they said the mangoes which are in uniform color, like completely in yellow color, or so uniform color. So those are naturally, those are chemically treated, okay, artificial ripened mangoes. And if you see some patches like green patches and it looks still like green color, then they said it is naturally ripened mango. Okay, and there is one more secret behind this to check. It is my okay. So suggestion: when you buy the mangoes from market, what you do, you just dip the mango. Take a so water in bucket, and you just dip it. Okay, if it floats, then okay, you can think that it is chemically ripened mango. Okay, because somewhere in the video I've seen, I've got this information. So if you dip it and if it floats, then you can assume that it is chemically ripened mango. Okay, and put it in the water, and if it sink into the water, then it is naturally ripened mango. Okay, so but of course with this idea you cannot propose any machine learning model, but you can think of it. If it, is this possible to propose machine learning model with this idea? But we have done with the image processing technique by capturing the images. Just a second. Yeah. So these are the data samples we have collected for the naturally ripened mango and calcium carbide treated mangoes and ethereal solution. So these samples I have collected during 2015. And if you just look at the first two samples, the class samples like naturally and chemically treated mangoes. So don't you think it, these mangoes look same, right? See, when you look at these two sets of mango, okay, appearance wise, it is same. Okay, like appearance wise, the features are same. Then it was, then even I got confused, like how we can differentiate these two type of mangoes, natural one and calcium carbide. And there was one more solution at that time, that is ethereal solution. So I had to dip all the mangoes into this solution and to kept it for so ripeness. Okay, and in the later stage, but when I collected these mangoes, and of course when I collected this data set, I've used nearly 7 different cameras. Okay, because I had to capture with the different resolution cameras, right? When we just proposed this idea, we thought, so why can't we build a simple Android application, so that if you go to market, okay, it's something like available in Google Play Store. So if you download it, and okay, even if it is not free, if you can download and if it is chargeable, but still, so why can't we have this application like Android application, where when you go to market and capture the mango image, so it should tell whether it is a naturally ripened mango and calcium treated or chemically treated mango. Okay, so keeping that in mind, we have taken images with using 7 different cameras, a resolution varying from I think so 8 megapixels to 20 megapixels. Okay, and as we got less accuracy with this with these mangoes, like data set in 2018, and as the mango samples like data set were not sufficient in 2018, by that time like Indian government had banned this calcium carbide, where I had used during 2015. Okay, and then because I had to collect few more data set, when I inquired the type of like type of ripener or ripening agent, okay, in the market, they just provided me this kind of sachet. Okay, can you see the sachet here? It is like, it is mentioned as gold ripe and ethylene ripener. Okay, and so there was no details about the ripener, like where it is manufactured and so how it is being manufactured. So nothing was given. The information was not at all given. And when I just see, can you see the sachet here? It was something like this inside the big packet. So I could have, I could get the many some 50 sachets. Then when I inquired, people who sell who sell mangoes. When I inquired them, so they said it is a China product. We don't know what it is. Okay, they were just using these kind of sachet for ripening process. So, like without having any details on this packet or on this sachet, so don't you think it is even more dangerous? Because why I wanted to mention this here is, when I used this sachet in 2018 to collect the data set, so within 2 days, it took only 2 to 3 days, 2 days to get ripened. I mean, the entire, because I had kept nearly 200 mangoes for ripening, all like 200 mangoes got ripened within 2 to 3 days. Okay, then I assumed this is even more dangerous. Okay, and it was the color. So look at the color here. Okay, like after capturing the image of these mangoes, okay, chemically ripened mangoes, look at the colors. It is completely okay, the entire mango is in one color, like uniform color. Okay, and this is the natural one. And it took, for the natural process, it took 10 to 12 days to get ripened. And people do not wait. Okay, people do not wait for mangoes to get ripened naturally, and especially for 10 to 12 days. Isn't it so? They want money immediately, right? So again, I thought that this is even more dangerous. So please be careful when you buy mangoes, okay, in the next season. And as I said, what you can do, so you can get the mangoes, and better you put it in the water. So if it floats, then please do not eat, okay? If it sinks, so you can have it. Yeah, so for that, we have, like I have used different ML approaches, like conventional method. Okay, so wanted to propose a model like what could be the best of color and best of texture feature, and with using all the different types of classifiers. Okay, and then we have also proposed like used deep learning techniques. Only features were extracted from the pre-trained model. So there are many pre-trained models. Okay, so like VGGNet and ResNet, GoogleNet. So with these pre-trained model, we have extracted the features, and those features we have so given as input to the classifier called SVM. Okay, so deep learning architecture and trained using SVM, support vector machine. Yeah, so with this conventional method, we got some 60, almost like 60, 70% to 85%. That is by having best of color feature. Okay, so if you want to know more about the model, you can refer to my paper, okay, published papers. And best of texture features, we got some 75 to 78. And this conventional method I've used for the data set which I've collected during 2015. Okay, and in the later stage, as I had used this data set, it was so easily recognizable. See, look at these images. Easily you can say which is the natural one and chemically ripened. It looks uniform. So for this data set, when I applied the same, especially using deep learning, so I've got nearly 98% of accuracy. Yeah, so these are some of the results which I've got it for best of color feature and best of texture feature. Okay, so it is using deep learning technique, as I mentioned. So I've used AlexNet, GoogleNet, ResNet 50, and 101, VGG 16, 19, and Inception V3, where okay, so here I've got a better result using ResNet 50. Right, it is almost closer to, yeah, so I think this is a different one, but I've got nearly 98%, so 97 to 98% with the deep learning techniques. I think before we proceed to the next issue, so can we go for a break? As you mentioned, it's 7:50. Shall we take a break now?
Yes, ma'am.
Okay. Yeah. So be back at 8 o'clock.
Yes, ma'am. Thank you.
Thank you. Hi, everyone. Welcome back to the session. So I hope you're all back.
Yes, ma'am.
Yeah, thank you. Sorry. Just a second. Okay, do you have any questions to ask? You can let me know if you have any questions. Yeah, so kindly feel free to ask if you have any questions. Before we proceed to the next one. Shall we proceed? Quick confirmation. I think no queries, so we can proceed. Yeah. And the next major issue is internal defect detection. Because when you look at the mango, I mean to say an external appearance wise, you do not find any, like spots or anything, okay, in the skin part. But when you open it, when you when you open the mango, okay, when you cut it open, so you would find these kind of patches. Have you noticed these kind of patches? We call it as a spongy tissue or soft tissues. Okay, see, this was the major reason. This was the major reason that, so many countries, especially European countries, had banned Indian mangoes. Okay, have banned Indian mangoes because this was the proposal. Like when I started my research work, so I got this problem from CFTRI people. So I don't know whether you have heard about this research center, like food research center, which is in Mysore, okay, which is located in Mysore. And, so I did almost 1 year survey to know what could be the cause. Okay, I mean, what could be the reason that we get soft tissues inside the mango. There were many reasons, like due to calcium deficiency, because when I inquired in university, like agriculture university, so they said it is due to calcium deficiency, sometimes even due to high temperature. Okay, the areas which are so areas which have high temperature, especially mangoes grown in such areas like Maharashtra. Okay, so yeah, so there we find high temperature. Okay, so in those areas, so mangoes which are grown in those which are grown in those areas, you would find these kind of patches, like white patches. And as I said, we call it as a soft tissue and spongy tissue. So still research is going on this. Okay, and as I mentioned, I spent almost 1 year to check what could be the reason, okay, to have these kind of patches. And is there any solution to identify, like not in destructive method, because in destructive method it is fine. So after, we cut it open, so we can easily see it. So that should not be in a destructive manner. So it's supposed to be non-destructive technique. So is there any possibility to check the internal defects which appears in mangoes with a non-destructive technique? Then, like, so we have, we have tried with a different type of, so I just did a survey to check whether is there any devices or any research is going on this to check the internal defects on any fruit, okay, not only in mango, so that we can make use of the devices where it is already where the research is already going on different fruit, so we can make use of the same device to check the internal defects in mango. But again, I spent almost 1 year, so I was unable to get the device. And almost after I did survey, so I got to know that it is possible after referring many literature, I got to know that it is possible with the NIR spectroscopy, near infrared spectroscopy. And when I inquired the availability of NIR spectroscopy in many research centers, it was not I was unable to identify where it was available. I searched in IAC Bangalore and many more research centers. And when I checked the cost of this, where if possible, we can buy in a research center, from our university, the cost was 70 lakhs. Okay, when I had inquired, the cost of this spectroscopy was 70 to 80 lakhs, which we cannot, of course, not affordable, right? And with this, so we had, proposed, like we had written a proposal to CFTRI and to Indian government, like central government, to release this much amount where we can do further research to detect the internal defect, because that was the reason. That was the reason where most of the countries have banned Indian mangoes. Okay, major issue was this, and like as I mentioned, so there was there is a huge loss to Indian economy. Okay, and unfortunately, so it didn't get approved. The proposal didn't get approved, and later stage, because I made this as one of the objective in my research work, so I had to get the solution for this problem. Then I spent almost again 3 years, 2015 to 2018, but during I could solve the first two problems, like classification of artificial one and natural one, and other one is like ripeness evaluation. But I was unable to get the device where it can detect the internal defects, especially with NIR. I was looking for NIR spectroscopy. And fortunately, in 2018, so I got NIR spectroscopy. It was not in any research center. There was a company in Bangalore, so they were. It was commercialized. They were just selling this product, NIR spectroscopy. Then, we have so convinced them to get some data set, and if this gets approved, if we get a better result, or if this paper gets published in a very good journal, I'm sure we would like to have, we would like to buy this NIR spectroscopy to our research center. And they just allowed 2 days to collect the data set. So as I mentioned, I had to carry some set of samples, okay, from Mysore to Bangalore, where when I mentioned the challenges, worms were coming out of the mangoes, okay. So there were a lot of issues and challenges during the collection of this particular data set. Okay, you can find the defects in a spongy tissue, or and when we referred the literature, we found that mangoes are already have been sorted using X-ray technique. Okay, using X-ray technique, that is in, I think, in some research center which is located in Chennai. But so when we sort any kind of products, products like X-ray, okay, or any these kind of ionization radiation technique, so that must be labeled, especially in foreign countries. So that must be labeled as a warning label. That must be keep it as a warning label in supermarkets. Okay. And when consumers look at those warning labels, like when these kind of mangoes are being sorted with X-ray technique or something, so people might not buy, isn't it? Because they think that, again, ionization radiation might not be good. Consuming such kind of mangoes might not be good, okay, due to this X-ray. Okay, though even though they use very less, it gets sorted with a less voltage or something, but still, so they assume that it is not good, okay, with the X-ray technique. And Yeah, so as I said, somehow I so got the data set where we had to, like, I'm here, so where I'm collecting the data set here. Okay, it was not in it is not in terms of images, it was like, some radiation kind. So we had to project this samples with the radiation, and we were getting the result in terms of, we were getting some values in the form of reflectance. Okay, so reflectance versus wavelength. This NIR, that is near infrared spectrum, near infrared rays, wavelength varies from 700 nanometer to 2500 nanometer. Okay, so below the 700 nanometer, you would have observed in electromagnetic spectrum. In electromagnetic spectrum, we have certain range of, so wavelength, 300 nanometer to 700 nanometer, you would find visible spectrum. Okay, that what we see. Okay, today what we see or what this camera captures, it's all like, so visible spectrum, right? 300 to 700 nanometer. Just above this visible spectrum, you find infrared rays. Okay, infrared wavelength. And NIR wavelength varies from 700 nanometer to 2500 nanometer. So where we had to capture the data set with this range, like 700 to 2500 range. But still, so identifying the internal defects in any particular wavelength was very, very, it was quite challenging. Okay, see, it is a wider range, like 700 to 2500. So that is the challenging part in NIR. So choosing a particular wavelength, or so a very small range of wavelength to identify the internal defects. Okay, yeah. So okay, and to create the ground truth. So these were the samples I had taken. We had taken it for the experimentation, and I had to cut each and every mango to check whether it is defected or not, something like this. Okay, can you see the defect here? So especially to create the ground truth. So creation of ground truth is equally important, isn't it? So after getting the like reflectance value, so we had to cut each and every mango. So these were the defects. And this was the data set. We got it like reflectance versus wavelength. Okay, you can see, because as we have used two different optical fiber, one would vary from 600 to 1100 and 1100 to something nearer to 2000, 1900. Okay, and these were, let me use the pen here. Okay, so can you see the difference here? So these are the samples, these are the graphs, okay, related to. Okay, so these were the samples belonging to so like the defected one, and these were the samples belonging to non-defected, internally non-defected one. Can you see the difference here? At least there is a small change, or where we can apply some filter, or where we can apply some kind of threshold. Okay, so these were the samples belonging to non-defected, and these samples belonging to, okay, so these were the data set or samples belonging to defected. But when you look at the next part of it, next part of the wavelength, we're ranging from 1100 to nearer to 2000. So where you cannot at all separate. See here, all the samples are mixed, both the defected one and the non-defected one. Okay, then we have identified, just by looking at the graph, we have identified. So with this range, it is not possible. That is from 1100 to almost 2000, it is not possible. Then we have, so focused, or we have concentrated on this range, like 700 or 680 nanometer to 1100 nanometer. Okay. And yeah, so like we have used Fisher's linear discriminant transformation to select the feature, because see, there were, you can see the wavelength range 680 nanometer to 1100 nanometer means like it is like 680 nanometer, 681 nanometer. Okay, so keeping some like 0.5 nanometer, so we could get so many, almost 1000 features from these samples. Okay, we could get some 1000 features But again, we wanted to check on which particular range of wavelength it works good. Okay, because here till this it is not, isn't it? Can you see the difference at this point? Okay, especially after 700 nanometer, you are able to segregate, you are able to separate these two set of samples. Okay, till this it looks same, it is almost same. Okay, where you can see the dip. Then like as we wanted to check with the particular feature or particular wavelength, so we have applied feature transformation technique. Like we have concentrated more on feature engineering techniques like transformation and feature selection techniques like Fisher's ratio and dispersion measures such as mean absolute difference, mean median. Okay, I have published a very good paper on this research on this particular problem, so you can refer to that later. It has been published in elsewhere. And with this, by analyzing all these techniques, then we have understood using Fisher's ratio with the less range of wavelength. Okay, these are some number of wavelengths. We were able to get some 85 or 85% of accuracy. Okay, and of course here also you can see a good accuracy, but after taking all the 1000 features, you can see here. So that is from 0 to 1000 means after considering all the 1000 features, we are getting maximum accuracy. But here again, after taking some number like 300 features, we are getting some 80% of accuracy. Okay, but in this case, using Fisher's ratio, by considering only less number of features, less than 200, we are able to so get maximum accuracy. Then we have identified, so this will be the suitable one to optimize the wavelength. Okay, and later we have tried with a range of wavelength. Okay, like on which wavelength it is, like which are the features contributing to have or to get the better accuracy. And this is with respect to arithmetic mean and geometrical mean, Fisher's ratio. But as there was no consistency, you can see the scattered output varying from 700 nanometer to 1100. So here it is very difficult to identify on which particular wavelength you are getting a better accuracy, as it was completely distributed, scattered. Okay, even in AM/GM. But here, look at this. So here we have it from I think 700 to 750. Okay, these are the wavelengths where you can see maximum accuracy. That already we have identified these wavelengths, but we have so tried plotting it in a different fashion. And in these using these techniques, it is completely scattered. So finally, we have proposed a Fisher's ratio. So it would be the best one to choose the prominent wavelength range. And we have also tried with the so based on the relevancy score, we have tried with the first rank feature. I mean, when it is once it is selected, so we will sort it out based on the relevancy score. So the feature which has a high relevancy score, that would be treated as a first rank feature, and the second rank feature. So again, we have tried out with the first rank, second rank, and third rank. It's like something like a wavelength. Okay, so first rank means it is it belongs to one wavelength. Second rank means belongs to another wavelength. And I have also tried with the fusion of this. Okay, so finally, yeah. So this is the accuracy we got it. So we were able to reach almost 85% with this number of wavelengths. Okay, and finally, so we have proposed that it works good between 702 nanometer to 732 or 750 nanometer. I don't remember the exact number. Okay, you can refer to that paper later. Okay, I think I've discussed about all the issues. Yeah, so all the issues and the solution for these issues, but still, so there are many issues opening. Okay, to do further research. Those are overripe mango fruits without black spots can be considered. So already we have taken this category, but in this category, But as we could get less number of samples, okay, I showed you in the data set. So we could get only 50 samples for this class. So if anyone is interested to work for it, you can even contact me, and I can give you some idea. Okay, in the later stage, you can consider these samples. You can concentrate more on these samples. Okay, as much work is not done. Okay, research work is not done on this, right? And the samples were not collected. More number of samples were not collected. And so one can also look into develop Android application with ML model, that is for especially to categorize naturally ripened mango and chemically ripened mango. Okay, so ML model can be used to develop as an Android application at the market level. Okay, it should be like real-time application. It is for consumers to create awareness of consuming artificially treated fruits leads to many health issues. As I needed more number of data set, so we could not develop Android application. So one can think of it in future. Okay, and there was, so one more interesting issue that I wanted to highlight here. So after I collected the data set and after I published many papers on the same models, like these issues, when I just, so one day I just went to the market and inquired like elder person. Okay, just out of curiosity, I just inquired elder person that can you identify, because he was selling mangoes. And when I asked him that, can you recognize, okay, can you pick some mangoes, okay, which have internal defects? He said, of course, it is possible. So I can pick it up. But he was surprised and he was shocked because I was looking into only the mangoes which have internal defects. Why she's asking these kind of mangoes which have internal defects? Then I told him, no, I'm doing some research on this area where I want to know, internal defects in mangoes. Then immediately, so he picked some mangoes, and I wanted to buy some 2 kgs of mango. Okay, he picked some mangoes, and he said you can go and check. So I'm sure there will be so internal defects inside the mangoes, like white spots or spongy tissues. So I was also surprised, and I was so curious to know. Whether it has all the mangoes have internal defects. And I asked him, so on what basis you are selecting the mango, you are picking the mango? So he said, so any mango, okay, especially this occurs in Alfonso mango, okay? Alfonso mango. In Alfonso mango, if the mango size looks bulge, okay, I don't know. So this time, so you can notice that. Because Alfonso mango has a standard shape, isn't it? But the mangoes which have bulge shape means it's like, so for example, if the mango, the standard shape is something like this, and if it is bulged one, so you can pick those mangoes. That he said that is the major feature where you can identify, or where you can so consider, okay, so it has a internal defects. Then I was really so surprised to hear those words from him. Then I so came back, and because as I said, I was so curious to know whether it has internal defects. But unfortunately, I did not take the picture of those mangoes because I was so curious to just know, to know whether it has internal defects. So immediately I came back and I just checked all the mangoes. Do you believe it or not? All the mangoes, like out of, I think I bought some 10 mangoes. Out of 10 mangoes, 9 mangoes, okay, had internal defects. So what do you say about this? See, I spent almost 1 year to do survey on that. And then so we thought that again 70 lakh, it's a huge amount to buy NIR spectroscopy to detect internal defects. But And later, after I did my research, I got to know this idea where still with the human vision, okay, or still with the normal camera, so we can detect the internal defects in mango, which appears in Alfonso. Okay, so then I felt this is quite interesting. So if anyone would like to take it up, so yeah, it would be appreciated. Okay, so in future. Yeah. So thank you so much. Thanks for patience listening. If you have any queries, you can yeah, so feel free to ask me. And one more thing I want to highlight. Somewhere I have mentioned that due to calcium deficiency, you get that internal defects in mango. Okay, that I have so read it in literature and some theses. Okay, then I like you can also look into that in future. So can we? Because see, once you pick it up, then only you will okay understand that, because so there should be some 200 mg calcium, okay, in a healthy mango, right? So there is a number. I don't remember the exact. Okay, so I don't remember the number, the exact one. It's like 200 mg calcium should be there in healthy one. If it is less than that, it is sure that there will be an internal defects in mango. Okay, so that we got to know. But in future, so anyone can look into that. Like, can we build or can we have calcium detection sensor? Okay, can we have a sensor where it can detect the calcium content in the mango? Okay, not after cropping it, like before you crop, that is in yield crop, before you pick the mango from tree. So can we use these kind of sensors? Can we use these kind? Because once you pick it up, it will not grow, isn't it? Like once it is matured and once you pick it up, so it cannot have like more calcium. So what you can do, like I know I'm just giving you different ideas. So if anyone is interested to so proceed this research, you can do that. Okay, so can we have these kind of sensors, like sensors which can detect the calcium content? Okay, that is at the mango which is in tree, right? If it shows less than some value, so can we inject some calcium, or in any other way? So can we so it could be in any way. Okay, so in any other way, can we inject the calcium so that by the time it gets matured, by the time the mango gets matured, so it will be okay, so it will be healthy one. So one can also look into this. Okay, as you get calcium, as you get internal defects with the calcium deficiency, so you can have so variety of problems. Okay, so with this, I would like to conclude my session. Yeah, so any questions? So if you have any questions, I hope the session was interesting, because I wanted to highlight only the research part, not with the technical details. I've used many ML approaches, like ML models, that is in the stage of feature engineering, like extracting the different features, as well as in the classification. Okay, so you can continue the same research. Yeah, always one more suggestion I would like to give here is, if you want to pursue your PhD or research, okay, please do not stick on to one a specific area or one specific technique. So try to explore it. Okay, try to explore with a different technique, right? So a wide range of experimentation is required. Okay, extensive experimentation is required to have a better result. Okay, please, and moreover, those who are using deep learning, please understand what's going on and why it is needed. Okay, so why we need to, because like I told you that in my research, I've used a pre-trained model. Okay, whenever you are using pre-trained model, try to understand why do we use this pre-trained model. Okay, and the models, like pre-trained models, have got trained for what kind of images. It's not like only getting some 98% or 90, so getting that kind of result is not going to be a good research. But at the same time, you need to look into why you are getting that percentage and why you are not getting the remaining percentage, like error. Okay. Yeah. So with this, I would like to conclude my session. So any queries?
Participants, if you have any queries, please try to ask, ma'am.
Yeah, I would like to take it up if you have any questions. If the session was not boring.
Ma'am, let's wind up the session, ma'am.
Yeah, so I think if no further queries, you can. Thanks for patience listening.
Ma'am, I would like to give a vote of thanks to you, ma'am.
Yeah, sure.
It has been such an honor to be a part of this wonderful event, sharing session with you. I would like to thank our Honorable Chairman, C.H. Malareddy Garu, and our Principal, Dr. A. Ramaswamy Reddy Garu, and also Atal FDP sponsored by AICT. So on behalf of all the participants, I would like to extend my heartfelt gratitude to you, ma'am. The topic which you have covered in this session is informative for all the participants. And I also would like to sincerely thank all the heads of the various departments and deans who participated in this event throughout. And a wide round of applause and thanks to all the participants who made the event successful. Thank you, one and all.
Thank you, madam.
Yeah, so here I've shared my Gmail. Okay, so email ID.
So if you have any queries regarding this session, you can directly.
Sure. Even after the session. So if you have any queries, you can, so ping me personally at any point of time. Okay.
Okay.
Yeah. Thanks.
Thank you, ma'am. It is so it is much informative, and we are very happy to share your knowledge with us, ma'am.
Yeah, it's my pleasure to be a part of this event as a resource person. Thank you.
And also participants, we have shared a link in the group. So the participants who want to take a bus facility provided by MREC College, you can please fill the details in that link, through that link, and so that you can avail the bus facilities from Tuesday to Saturday. And I would like to thank everyone, and here the session ends. Thank you, everyone.